Welcome to Jairam YouTube channel. So here we see videos or we try out many cybersecurity stuffs. So in our previous video, we have already seen about the BITM attack, which is the browser in the middle attack. Why we have explored that is like we heard like or we just got to know or from the research like attackers still use this BITM attack as one of their methodology, to eavesdrop or like to gain sensitive data from the victim. As we all know, MITM is a kind of a renowned technique which attackers used before. BITM is also one of the oldest technique as we discussed in the previous video. But I thought to make this video a little more interesting because the previous video we covered about the basic the POC, like the proof of concept, which covers like a victim being phished, and we are just trying to run some JavaScript which fetches some sensitive information from the victim, and then we are trying to log it into our WebSocket server. But in this video I'm just trying to make a realistic approach like how a real attacker setup will look like how the victim will be phished, and how they are just how the attacker is setting up his own what to say like attacker domain to just get this BITM possible. In this scenario or in this POC, we are going to have or like we can still set up in a single server, but I just try to have like two servers, like two virtual machines. One I'm just running a Kali, so I just call it as an hacker pod. So this is where like a majority of the architecture of the attacker it's going to be configured. And I also have a Ubuntu machine here. So I just named it as C2 because I'm just going to configure some of the important tools in this virtual machines, like the SMTP servers or like the proxy servers here. So I just call it as C2. There is no such kind of I didn't have any kind of a C2 server, but I just had it for a name, just a C2. So here we have two virtual machines, which is going to be part of the attacker domain, and we can simply run any OS or like any virtual machine to just mimic a victim user. So let's just start quickly with configuring the attacker domain. So here, as you know, like we have a Kali, and let me get this here. So yeah, so here let's check the IP. So we are just having a 10.2.0.4, and the configuration is I'm just running this two VMs in an isolated network and that network. So they have been segmented in the 10.0.2 /24. Like I have it as 4. I think the Ubuntu still has it as 10.0.2.6, I guess. So what we are going to have in this virtual machine. So as you know, the BMTM attack, like I will just try to cover what the BATM attack comprise of. So first, like we need to phish a user. So for that we need a phishing website. So let's configure step by step. So the first step is let's focus on the phishing server. So let's start setting up a phishing website actually. So what we will have here is like we will have a Apache web server which will host our phishing website. So we have configured, or we have already have a phishing site which we used in our previous POC. So I can still show like what does we have there. So so if I go to the Apache server side, so here as you can see I have a index.html. So what does the index.html have? So there is like I think three files which is responsible, like which is kind of a heart of the phishing website. So one is the index.html, and the second one is attack.js, and then we have one more JavaScript which is stealcreds.js. This is where our a listener, a WebSocket listener runs. So this is a simple web page like which resembles like a OAS Jew shop. So in this concept we have taken OAS Jew shop as our real website. So we are just trying to create a phishing website which is a lookalike of OAS Jew shop. So I have created a HTML which looks like OAuth shop, and which in turns call attack.js. This is where most of the logic lies. So this attack.js, what it does is it has a logic or a module to capture all the username and password details which the victim enters, and it sends back to the listener. Like we have a JavaScript here which runs the WebSocket listener, so it will just try to grab all the keywords, keystrokes, and then it tries to push it to the listener. So how does it looks like? So let's get a look on how does this index.html looks like. So as you can see, he just kind of a style sheet here, and then as you can see here, there is some kind of the header names and all this one, and here you can see there is a username, password, and then a login button there, and this it turn calls the attack.js. So what does attack.js has? So attack.js has a logic where, as I said, like it opens a WebSocket connection here, and then it sends to the listener there. Like it gets all the keystrokes which the user enters in the login field, and then it sends the data back to the listener, like which has been configured here. So we need to make some configuration changes because our okay, so sorry, this it's to be. So I think our Ubuntu server is the I think we will be listening here. Okay, then I think the current attacker Kali is 10.0.2.4. So let's make the changes here because this has the uh, configuration on the lab which I run to just check whether it works properly. So I think that's where the previous configuration is still reflecting here, but let's update it to the existing configuration. So this is again um, to be here, yes, and then yeah, I think this should be done. And let's also check the WebSocket listener, what we have. Um, Steel.js. So what do we have? We have just a listener, and then it just stores all the keystrokes which it got from the from the attacker.js, and then it stores into a stolen credential.txt file, where you can go and see like what are the keystrokes or the username and the passwords in the plain text actually. So here I think we are running on this one, so let's change it. So now I think we are clear in what we have inside the what we're going to host on the Apache side. So what we do is like let's just start the Apache. So I think let me check whether what is the status of it, whether it's already running or yeah, it's actively running. So I think like it will run on 8000 because I have configured to run on 8000 because I will be using some proxies on 8080 or 8010 or 8090. So I just configured the um, default port to be 8000 exactly. So let me run it on, see, there is no SSL layer, localhost 8000. See, so the real OAS juice shop will look something similar to this. I can still show the real website after this one. So this is how our phishing site. So I just had this note to deliberately show the viewers this is a phishing site. So we are currently rebuilding our application. No worries, please proceed with the signing. So here, the logic how it works is let me enter a email and then a password, and then if I click login, you will be shown login, please wait. If you click OK, like the attacker.js JS will send all the keystrokes to the listener WebSocket listener, and then it will redirect the user to original site. As you can see here, the IP changed to 3000 because we will be running or hosting a original site in this POC, but in real time we will be forwarding it to the original site, which is like just type https oasjuiceshop.com or something. So the user will be landed to the original OAS juice shop here. So now our phishing site works good. Then we need to fix this one. So we need to get the real OAS juice shop up and running. So let's go back. So don't confuse like why we are hosting the original site. So I'm just trying to sandbox this environment, so I'm not going to expose our box to the outside world for safety purpose. So I'm just trying to mimic the real website as well, like something is hosted in the internet, so we are just trying to use it. But here, as it is sandbox, so we are just trying to host it in our personal VM itself. So let's come. I just already downloaded you know um, the OS Juice Shop the code already in the local machine. So I think I have saved somewhere in the desktop if I'm not wrong. So let me just go um, and see. I think it's BITM, and then what do we have? WASP. Yep. So as you can see here, I have a Juice Shop binary already downloaded here. So what we'll do is like let's start running the OS Juice Shop. Yeah, just give me a second. Yeah. So we are just notice building the app, and it will start the application to run on 3000 if I'm not wrong. But yeah, we need to just go back to configure because as you can see, like it's been redirected to 10024. Yeah, it's perfect. Yeah. Um, hmm. So yeah, it started. Let's wait for the final confirmation on which port it is running. Yeah, so you can see the servers listening on 3000. So now if you go back, our chain will be complete. The phishing chain will be complete. So we have this phishing site which is hosted on 8000. So we just enter the details, click on login, and then all the details will be sent back to the WebSocket listener, and that's where the magic done. You see, this is the real website. So we have been forwarded to or redirected to the real website. So how does the victim? What will be the victim's experience? Okay, so there is something going wrong with this one. That's what happens sometimes with most of the application. So I just give the information. I know this is OAS Choose Shop. I got it from here, and I have the logo, and then I click on login. Okay, it's saying some pop-up. Okay, then I just redirected here, and then I remember after clicking some parts or like adding something. Okay, I'm not logged in. What happened? Something is wrong with application because they have already mentioned it. So let me log in again, and then he just gives it, and then some of the users like who are not aware of this phishing thing can still this attack scenario will be valid for them because trust, like most of the I think like 50 to 60% of the attacks come from phishing, and then there are users who clicks on the malicious link which when they encounter or a phishing mail. So this scenario or this attack path is still valid. So let's so one down from our list. So we have this phishing phishing module done and dusted. So we have the phishing, and then we have the redirect to the original site fixed. So what is the next step in the BITM? So once the user clicks, so where do you want to forward the user? So to the original site, that's okay, but we are not going to directly handle the phishing site in this attacker mission. Instead, as the name indicates, this browser in the middle attack. So we need to have a browser, or we need to host, or we need to run a browser which the victim will be accessing it from his machine. So then how the attack path will look like? So the attacker will be sending a phishing email. So the user, he will be clicking the phishing link. So after clicking the phishing link, he will be redirected to a application which is running in an attacker controlled browser. So which in turn it is running in an attacker controlled server. So so how it does that is like three parts. The user clicks the phishing link. The phishing links lands the user into a attacker controlled browser. In the attack, what is inside the attacker control browser? That's where the phishing site is hosted. And then where does the attacker browser is running? In the attacker control server. So let's just go to paint to just paint it, so that like we will have a real idea here. So sorry, say this is a victim, and this is the attacker control domain. And we will also have one more thing here. So what we have here, so this is the victim and this is the attacker. So the attacker will be sending a phishing email. So what does have in the phishing email? There will be a referral or a link which connects back to a virtual network, or a virtual environment, where the attacker has hosted a browser which runs the phishing website. So this is the phishing website, and this is the virtual environment which the attacker is running. So the link, whatever the HTTP link here, so when the user clicks it, he will be what will be seen in the attacker browser is that is, let's consider this as a browser. So here there will be web page like phishing attacker.phishingsite.com, something like this. But this is not a real application. So the victim will be accessing a browser which is controlled by the attacker. So that's why this attack is called as browser in the middle attack. So the victim will have no idea, like he just knows like he's just accessing a web application, but it is not a web application, and he is accessing this virtual environment. So this virtual environment is nothing but a VNC server. So this victim will be accessing this VNC server, which is running in a kiosk mode. Kiosk mode is something like not more access to the environment, is just kind of a view only mode or something like that. So I know I think like you are clear now. So we have what the victim will be accessing is the VNC server, which is running a browser. In our case, like we'll be running a Chromium browser. So what this Chromium browser will have, the phishing website on it. So this victim can see only the phishing website. He doesn't see the Chromium or the VNC server. So that's why like we are hijacking the user to our browser so that we can do anything we want. So let's go back. So now we have what have we sorted? So we have already sorted the phishing website part, which is hosted here. Let's just have it as phishing domain. So this thing is sorted, but we need to configure this hot. This is the VNC thing hot. So let's open a new tab, and then what we do is like we need to configure a VNC server. So in order to configure the VNC server, so and also we need to just have some startup scripts, so which will be on if you just install some VNC, like I have Tiger VNC which is already installed. You can always use any VNC like Tight VNC or any other VNC server you want, but I installed a Tiger VNC. And what we have in the startup script is like, as you can see here, I'm just starting the VNC with the resources, and then I see during the startup I'm just mentioning there should be a Chromium browser which needs to be spinned up automatically. And all the as it is a browser, we can still configure the proxy settings, so all the traffic from the Chromium browser is to be sent to this server. I will just tell you in the next phase like why. So all this traffic from the Chromium browser should be proxied to this server on 8082 port, and then this Chromium browser should run on kiosk mode. So why kiosk mode? So because the user should feel it like an that should not feel like that is a browser running. So you just want to feel there is an application is running. So the kiosk mode make it possible so that like you have lesser access to the Chromium browser. You just see a window, just the application, not the Chromium browser or not the VNC server which is running the Chromium browser. So this is where this is our target, the C2 server, which I'm just calling the Ubuntu server. So that's where we are just going to run this what to say the setup actually. So this one, this is my C2 server, and here I think we need to change it to 10.2.4 here. 10.2.4. This is nothing but our phishing website. So we are just want to run it in the kiosk mode on this URL. So we are just trying to run the phishing website on the Chromium browser. So that is what the configuration is. So let's go back and let's start running our VNC server. And what we will do is VNC server. So this :1 is something kind of the first instance of the VNC server, and then we have some geometry to have the the what to say the window configuration, I would say. And there is a one more important thing which we need to configure, is nothing but the security option. Security types is equal to none. So why we are just having the security type is equal to none is whenever we are using a VNC server, the VNC server will be asking for a username or like a kind of an authentication to get logged into the virtual server, just kind of an RDP thing. So how you log into RDP, you just enter the credentials and then you just try to log into the remote desktop. So just same like that. So this security type none, what it mentions is like don't ask for any authentication. So why we are just doing it, say you are the victim or we are the victim, we just get some URL, let's say a VNC URL, we are just getting phished, and you click it and then you see something like VNC server connect authentication needed or something. Then you will be kind of you just stop it there, like no, this is not the web application I'm just trying to access. So we need to just make it more realistic, so there should be a no intermediate authentication. So that's why we're just trying to put this security type equal to none. So let's start the VNC server. So what does this say? The user can access without authentication, clear break, network one. Okay, there is something wrong. Something is wrong with the startup thing. So maybe I have messed up something there. Huh. I did. I did mess up something here. Hmm. What did I do? What did I do? See here? So now we should be good running it. So as we can see, yeah, it is running. And then what we can do is so now what we've done is we have created a VNC server, or like we have initiated one virtual VNC server, which is running a Chromium browser inside it, in a kiosk mode. And what is running on the Chromium browser is the phishing site which we have hosted. So now what we have did, so now we have configured this whole thing, you know, this VNC thing here. So let me clear it out and then try to get this one. So what we have done here, so we have a VNC server, a virtual server, or just consider as kind of a remote RDP, the machine which are going to RDP, something like that. Okay, so this is our VNC server. So inside this VNC server, what we have ordered to initiate a Chromium browser. So this is our browser, and so this is our Chromium browser. So what is running inside the Chromium browser is our phishing site, which has been hosted in our attacker machine. So we have now made this phishing path complete, I would say. So how we are just doing it? So we already have a phishing web server which is running on Apache. So we have the phishing site which is running on Apache, and now uh, we are just running this phishing website, or like we are initiating a session of this phishing website in a Chromium website or a Chromium browser, which is hosted or which is running or spawned on a VNC server. So this is how it is getting complete now. So how, and then what we need to do, we can just try to check it by spawning the other server which we have configured. We call it as C2. So as you remember in the startup script, we are just sending all the Chromium browser traffic to this server, right? So we need a listener or a proxy server to see like all the traffic from the browser. So for that, we will be using Burp Suite. Okay, it's in desktop, then I can just run it from there. So let's run the, sorry. So let's run Burp Suite. Burp Suite is nothing but a proxy server. So you can listen or like, intercept and see what all traffic comes from or like goes through the browser. So, so that is why it is. So let's wait for it to spawn. Close, not now, buddy. I will just update you later. And remember like on which port we are just trying to route the traffic here. As you can see, proxy server 10.02.6 on 8082. So we are just forwarding all the traffic from Chromium to this server on 8082 port. So then what we need to do is we need to go to proxy settings. Here, that's where the listener is. So click edit. So we are going to listen on 8082 because we are sending all the traffic from the VNC server to 8082 and to a specific address which is 10.02.6. So if you are confused like what this 10.02.6 is, that is what the IP of our Ubuntu machine. So now what we have did, so we have configured our listener or a proxy listener. So now we have made the VNC setup, or what to say, like the continuation of the VNC setup complete because we started listening on this one. So let's cancel it, put it. So as you can see here, the HTTP history is empty here, right? So what we will do is so let me just do this once again. So now what we have an attacker. So we have a victim here, poor victim, and we have a attacker domain. I will just have it like this. So inside that, let me just have two setup because we are running two VM. So one VM, it is called as you know HackerPod or something like that, whatever you name. But in our case, it's HackerPod, and the other one is C2, which is the Ubuntu machine, right? So what we have here, we have one component, which is our Apache, which hosts the phishing website. That is the lookalike of our OAuth 2 shop. And we have a second setup, which is our VNC server. What we do here, we have a browser hosted here or spawned here, which is Chromium. Chromium is a browser like Chrome. What does the browser has? The browser is running our phishing site, which is hosted via web server Apache, right? So this Chromium is in turn hosting our phishing website. And what does this C2 thing has? Here we have a proxy listener. We call it Mr. Burp. So this proxy, what does it listens? It listens on 8082. So why that is listens on 8082? Because this Chromium browser is been configured in a way that it should send all the communication through the proxy server, which is hosted on this website, this server, which is 10.0.2.6. So that's why we are listening on 8082. So what we can see here is whatever, for example, if I type google.com here, this google.com will go to this burp first. That's why we call it as proxy server. And then it goes to Google. So inside this burp HTTP history, which I showed, you will see an entry like this browser has made a call to google.com, like a get. And then whatever this user does in this Chromium browser, everything will be logged here. So that's why we call it as a proxy server. And this is what it's called as MITM. So we are just doing this eavesdropping, like we are just sitting in the middle and then we are just trying to get all the data from this browser. So, and this is our poor victim here. So victim here, right? So this is what we have currently now. So we need to make some more enhancement to make this more complete. So we will just do it now. So let's go back. See, we have already got something here because our website, it started hosting this 8000 thing, right? So that's why like you get all this HTTP histories here. So whatever will be spawned in the browser, the Chromium browser, it will be seen here. So let's minimize the C2 and let's go back to our HackerPod. So what we need to do now? So we have our phishing site and phishing environment, proxy server, everything ready. But the one thing is, we are planning to send. See, this VNC server will have a web GUI. We will just have it via, we have a utility called no VNC, which is kind of a front end, I would say. So this is a backend. Consider this as a backend, and this is kind of a GUI front end. So what we will do is like we will try to create a configuration so that like we have a GUI with some URL, HTTP URL, which is running on some port, so that we can send this link as a phishing link to the victim. Why we are doing it? Because we need the victim to access our Chromium browser. Why? Because when victim access our Chromium browser, we have made a configuration to route all the connections or all the traffic to our own listener, and then this thing should be forwarded to the original servers. So why we are doing it? We need to eavesdrop all the communication from the victim. So that's why we have just made the configuration to forward all the traffic to our attacker controlled proxy listener, which is burp, so that we can do or alter anything we want here and send it back. So why we are just doing this attack path? Consider this victim is accessing some banking site via our Chromium browser because he clicked the we know like the user is kind of a bank employee, so we're just trying to fish by sending him some link which will be redirecting it to a bank domain or something like that. So he clicks it, he in turn access our Chromium browser. So here he tries to enter his credentials, so everything will be logged here, but we will not be seeing it in like we can see it in plain text here, but once he logged in here, the session ID will be created. We can still see the session ID. We can steal the session ID and we can just, access it anywhere, right? We can try to hijack the session or replay the session, what the user is doing. So, so that's why we need, instead of accessing our phishing site directly, we are hosting the phishing site on a Chromium browser, and we are just trying to make the victim access our browser. So what we need to do is like we need to create this front end, so for the VNC server. So this front end, what it will have, so consider this as a front end. So this link, like which we send to the victim, will, when the user clicks on it, he will, the browser will open and he will see some URL like no VNC or something .html. But in the web page he will see our phishing website like OAS Choose Shop. So whatever he does in the OAS Juice Shop, he is doing the activity inside the Chromium browser, because the OAS Juice Shop phishing site is hosted on the Chromium browser, and the browser will send all the traffic to our attacker control listener, the proxy server, which is the Bob suite. So that's how we are going to make the user to know, to send all the connections to our listener. So let's go and configure the front end, which is the no VNC part. So in order to do that, we need this WebSockify. So WebSockify is a kind of what we can say, a kind of a proxy or kind of a router, we can say. So what it does is, it creates I just told you this front end, right? So what it does is it creates a connectivity between the front end and the back end. So that's what it does. So that creates a connectivity to the front end and the back end. So for that we need to route, right? So whatever it's coming from here, it is to route to back to the VNC server. So that's how we are going to do it. So WebSockify hyphen web. So that's where we are just trying to create a web front end equal to, and then we are just going to call the VNC thing. And what we're going to do is we are going to make it run on 6080. And then, so this is where the web front end will run on. So that will be a web GUI which is running on 6080, which is the no VNC web front. And what we need to do, whatever the connection comes from, like the 6080, it should be forwarded to our backend VNC server, because that's where the logic is. So that's where we run it as, all this connection should be routed back to 5901, which is nothing but the VNC server which is hosted here. You can see here, right? The new Tiger VNC server is created on port 5901. So that's where we are just trying to route the traffic. So it's just kind of a router or a switch, which what it does is, it gives a front end on 6080, and whatever you do with on 6080 will be sent back to the backend, which is 5901, which is nothing but the VNC server. So let's start the WebSockify. As you can see here, proxying from 6080 to 5901. That's what we said. So now that is a interesting thing. So what we can do is 6080, right? Sorry, 6080. I think oh, sorry. Oops. 80 slash vnc.html autoconnect equal to true. So as you can see here, while redirecting, it says no VNC, right? So this is what the GUI it gives. Okay. So this is what the GUI it gives. So this GUI is nothing but from no VNC, just the GUI. And as you can see here, the black window here, the black window is nothing but your VNC server, and this one you can see, right, this blue thing, this one is nothing but your Chromium browser which is hosting or which is running our phishing website. So why didn't we see any kind of browser search history or search bar or taskbar here? Because we made the Chromium to run in kiosk mode. So that's how this kiosk mode looks like. So now I think you will you have now got an idea like what we have done right now. So what we made is we have created a web front end using no VNC. So what it does is whatever when a user listens here, everything will be connected back to our VNC server, which is 5901, which is running on 5901. So this is running on 5901. So whenever you just access this web front, it will be routing you to this VNC server. Just kind of accessibility, I would say, easy accessibility of the VNC server. So now we have everything configured. So I think the old setup is working as expected now. But um, I think like I would say almost the setup is ready, but we will try to more beautify it. Before that, what we will do is let's go and check what I said. You know, so say this is the phishing site which I will be sending to this victim. Okay, so this will be the URL. I will be sending it to the victim. Which URL? This URL, which is nothing but the no VNC front end. So I will be sending this URL to victim. The victim will launch this URL, and what he does after launching it, he knows, okay, we are into this website. Let me log in, test at test.com, and something like this. And I click on login, and it says login, please wait. Yeah, we know. And we will be redirected to the original website here, and what we have done, we have already configured this Chromium browser to route all the traffic to our listener. So let's go back to our C2, and you can see, boom, there is huge HTTP requests logged here. So everything is from our Chromium browser. So as you can see here, this is where um, uh, you know the first hit to our web application, which is 80 on 80, 8000. I think here, yeah, and then there is connective. I mean, then it loaded the attack.js, and then after doing all the stuff, it's getting redirected to this 3000, which where like we hosted our real website, right? So you can see all the workflow being logged here. So that is one more interesting thing to do. So I will just show you right now. So I will just go here, and what I will do is let me just open a new window here, and let me go to so we had something called not the stolen steal credential.js, right? So I told you like it's a WebSocket listener which will be trying to fetch the keystrokes from the server, right? So we'll just try to run that one. So as you can see here, this is a WebSocket listener which is running on 12345 port. So I will just show you a simple demo here. So here you can see our attack.js has already triggered a WebSocket connect or a request to our WebSocket listener. When you just go back to our listener, you would have seen new connection established. So this browser, the JavaScript which we loaded, what it does, it already created a WebSocket connection. So whatever I type here, test.com and attack test POC, and then if I click login, all the keystrokes will be sent here. Okay, I think like I didn't have permissions to write here, sorry. So let me run that again so that I will just show you again. It's nothing but I don't have a permission to write on this directory. It's nothing big, I would say. So now let's reload it. Again, WebSocket is connected. I will just do attacker test POC as a password. So I'll be redirected to the original site. Let's go back to our socket server. You see all the keystrokes has been captured here, and the connection is already closed because we don't want to make some anomaly by keeping the open connection. So we're just terminating it whenever we are just done with the scenario, like kind of a red ops thing, red team ops thing. There is another part as well. So we can still go and see the plain text keystrokes which we captured, which will be stored in, sorry, which will be stored in stolen credentials.txt because that's where the logic is. You can see here, right? Username is test@test.com. Password is attacker test POC. That was the last keystrokes which we entered. So we had made two scenarios here. So one way is listening to this WebSocket listener, which we already configured it, and the other way is we have a proxy listener here which captures all the traffic from the browser. So anyhow, now we have all the details either by having a proxy listener or we have a WebSocket listener which captures all the keystrokes. So anyhow, the victim is trapped. We are going to get his details anyhow. So this is what we have already seen in the previous POC, but not this burp thing. But what I just want to make it more crispier. So what I did is let's configure all this phishing setup even. Not the phishing side. I'm just thinking about getting a go fish running where you can just try to send a phishing email and try to click or see like how the phishing email will look like. So for that, let host a SMTP server because we need an SMTP server to send email to and fro. As I told before, I'm just using a sandboxed environment. I'm not using any cloud SMTP servers so that like I can send any mails to Gmail or Yahoo or something like that. So I'm just trying to use the Papercut SMTP, which is a local SMTP server. So it doesn't have any connectivity to internet. So it has a GUI where you can see the email which you sent using the SMTP. So let's configure the SMTP server in our C2 VM. So what we'll do is, so let's see whether there is any Docker running already. Oh, sorry. So is there any Docker running? No. So then let's run the Peppercut a Docker image. Let's run it on just bind it on 1234 port, the web GUI from the Docker, and also 25, that is the SMTP listening port. And so this is the image which we are trying to run. Latest, right? So that's where the container started. You see a container ID here. So let's see now. There should be a Docker running, right? So what we have done here, we have kind of like pinned the GUI which AT which is running inside the Docker to our local port 1234. So what you can do is we can directly go to Mozilla or whatever the browser client you have and try to access the localhost 1234 so that you will access the Papercut GUI. So let's go here. HTTP. Sorry. See here, this is the paper cut, and this is kind of, consider this kind of a Gmail, your mail receiver or something, or mail provider, email provider like Outlook. So this is where you will receive all the phishing emails. Okay, so now we have configured the SMTP server, and we have our mail client as well. So now what we need is we need to have an environment where we can just use the environment to send a phishing mail. So for that we can use GoFish. GoFish is a well-renowned tool for phishing, where you can configure campaigns, um, select a group of users, and you can try to create your own campaign like most of the organization do for their phishing exercise. So let's go and host a GoFish, I would say. um, just come, and I already downloaded the GoFish and have it in my downloads. Oh, sorry. Mhm. Okay, let's go to downloads, and you can see there is a GoFish, right? GoFish plus, yeah, here we have it. So let's run this GoFish, and here you can see the admin server has started in localhost 3333 port, right? So let's go and see what we have here. Okay, so here, and I just want to tell you one thing. So whenever you just run GoFish for the first site, look through this logs. It will have your username to log in. As this is my fourth or fifth time running it here in this environment, so it is not giving me. So there will be a one-time password. Admin colon something here, which will be auto-generated when you run this GoFish, and you have to come here and enter those username and password, and then it will take you to the password reset page, and then you can try to reset the password here. Okay, so this is how the GoFish will look like. So this is the dashboard. Like it just shows you like how many emails sent, how many users clicked on the email or something like that. And this campaign is where you can create your own campaign. Campaign is nothing but the test you run, for the group of users. And here you can just create your users, whom you just want to send the phishing email, and check whether they are you know aware of this one, or they are just trying, or just simply clicks on the phishing email, so that we can try to educate them on this one. So here, this email template is where you just type the content of what should be there inside the email, right? And landing page is something like to which page you want to land the user. So you will have a button inside the email when the user clicks it, where the user needs to be landed out. And this sending profiles is nothing but the SMTP server which we have. So I think we need to reconfigure it, because we have a different IP now, because I flushed the DHCP thing. So I think yeah, we are running it on 6, right? So I think this should be 6. Mhm. Tester 10, tester 10 at test.com. I'm just trying to uh, see whether it's sending it properly. So if I click send, email sent, okay. So where this email will be sent? To our Pepper client. You can see here, default email from the phishing, right? So from tester10.10.com. So as this is a sandbox environment, whatever the email you sent, it will be redirected to this client, okay? But in the usual scenario, we can host a cloud SMTP server, so you can try to send emails to and fro to the trusted thing as well. But we have to make the email in such a way it's not being flagged by Gmail or any other email providers, I would say. So So now the configuration works perfect. So let's save this profile. So what we did is like I just gave a name, BITM setup Ubuntu C2, and I'm just trying to configure the to address, like who will be sending it, hr@organization.com, because I want to see myself as a HR of an organization which the victim is working, and this is the host where we have this the SMTP server hosted, and we don't have any authentication as of now for the SMTP server. So my sending profile is done, and the next thing is what I will do is like I will go to users and groups. I will create a group here, and then you can add users inside it. So I just added 3 users inside it, so you can still add how many users you want, and then I will just go and add an email template. So the email template is nothing but how an email should look like. So here you can see like I just named it as HR timesheet because that's what most of the workers in an organization will encounter. So I just want to name the sender as hr.payroll.organization timesheet non-compliance, and here I just created an HTML where it says like this is a reminder that your timesheet is not yet been submitted on all this one, and at last I have a clickable frame, so that when a user clicks on that, he will be redirected to the the landing site which we will configure. That's the phishing site which will complicate. So here this is the one. So this is how the template email template looks like. And the landing page, what does the landing page means? So I told you before, like where the user should be landed. So where the user should be landed, our phishing site is nothing but our VNC server, VNC, the no VNC web UI, which is nothing but this one, right? The 6080 VNC thing. This is what our phishing site will be. So we should give that here, and then we should configure it, and then we need to go and create the campaign. The campaign is nothing but I will just try to copy the campaign now. So here, what is the email template I need to use, which I already configured. Landing page is our phishing site, which we already configured. And the URL is our own, the current server root URL. And I don't want to do a kind of a schedule thing here. And sending profile is nothing but the configuration of the SMTP server, which we already did. And group is the group of user which I want, which are to be part of this campaign. So what will happen if I just click launch campaign? All the users under this BITM target group will get an email with the content of the template we already created and a link which will take us to take the victim to the phishing site which we control. Okay, let's launch the campaign. Launch. So now the campaign has been launched. It says email sent 3. Let's go back and see it in our email provider. See, there is 3 email now. So it says timesheet non-compliance because we have configured our email template in a way. So as you see, dear victim, this is a reminder that your timesheet for the current pay period has not been submitted. Please complete it as soon as possible. So here there is a complete timesheet frame. When I click here, it will redirect the victim to the phishing site, which is the VNC web URL. Let's see. See, it's taking me to the no VNC page, and boom, here I just have all the pages here, right? As you can see. So this is how the full real setup will be. I can just try to make something clear, like just show you the full the view once. So I will just try to reset the VNC now and just try to. So let's just try to just revisit the full attack path once and complete this video or the attack scenario. So what we do is like we have cleared everything up here. So let's go and see whether we have something in the um, where is it? Let me pull the burp from here. So let's just again run the burp suit and wait for it to come up and running. So then we configure it because I mistakenly closed it. So it's coming up. It's up and running. Yep. So now we have configured this on 8082. So that's where our server is listening. Yep. So now you can see it's a plain HTTP history, and we didn't get any. This is a default mail. I can even think so. We don't have any mail even here. So then we go here. So let's revisit it. So what do we have? We have a victim who we need to be phished, and then we have a attacker server 1 and 2. So the attacker server 1 has a phishing website which is hosted on Apache, and also a GoPhish which is hosted to create campaigns and then phish the victim. And inside that attacker server, we also have a VNC server which is a virtual server, and it runs a Chromium browser in kiosk mode. So what does we have in the kiosk mode? In the Chromium browser, we have our phishing website running on the Chromium browser. So, so how we are not going to send this phishing website URL to victim indirectly. We are going to make the victim to fall and use our browser, which is this Chromium browser. So he is going to use this Chromium browser. So what we are going to do is like we are going to make a web GUI out of this VNC server. So what we are doing is we are using a no VNC client. So we are using a no VNC client, or I can even type it little. Uh, it will be more easier for us to remember. So I can make it like this, and we are going to have a no VNC web UI, which is running on 6080, and there is a interlock connectivity between these two. So what does it does is there is a router or a switch. What it does is like it sends all the traffic from 6080 to the victim or the VNC server. Okay. So this Chromium browser is having this phishing website, and this VNC server is connected to a web front end which is running on 6080. So this is the phishing URL. We are going to use it in GoPhish to to be sent to the victim, so that we are trying to make the victim to visit this no VNC UI, which will turn connect us to this VNC server where our phishing website is hosted under our own controlled Chromium browser. So what do we have in the Chromium browser config? We have a config to route the traffic to our C2 server. So what it does is it routes all the connection back to our burp suite. We can see all the logs here, like whatever the victim is browsing. Okay, so what we are going to do is like we are just going to configure this URL to GoPhish. So here I will just show you step by step. So here in GoPhish, let's go create a campaign, just delete it, create a new campaign, not a new campaign, I already have one. Let's mirror it, select a group, launch campaign. Okay, so see, we have sent the URL. So what we have sent it, so here if you go and see, email is sent to victim. We'll just go to the email and see. Here is what the email looks like, and it says us to complete the timesheet. So what we have done, so we have sent the phishing URL, that is a known VNC URL. We have configured it in GoPhish, and we have sent this email to victim. So now victim has got the phishing URL, I mean the phishing email. So once I click here, So I'll go here. I am a victim. So I'm just clicking here and see he has got the phishing website which we created. So what is the path here? So victim clicks it. So he in turn access this GUI. Okay, so this is what we are seeing it here. So he's access this GUI. So this GUI is what we see here. See, this juice shop is the phishing juice shop which we have hosted in the Chromium browser. So this traffic is in turn redirected to our Chromium browser. So where is now the victim is? So the victim is now under the Chromium browser which we control. So what we have in this Chromium browser? In this Chromium browser, whatever the victim is trying to visit will be in turn sent to our Burp Suite. This is our local listener which we have already configured. So whatever is sent, like whatever the victim access it in our Chromium browser, it will be sent to Burp Suite. So let's do it here. So I will just go here, test at test.com and test. So here I'm just trying to log in. Start test.com and then test. So I just logged in. See, he is getting redirected. So this is exactly the Chromium browser, right? So what I was just trying to do is exactly the Chromium browser here. So whatever I do in the Chromium browser should be redirected to my the Burp Suite, right? That is what the listener is. So here, as you can see, all the traffic from this is already logged here. So we can see all the traffics here, like whatever the user has accessed here, and we can see whatever data we want because this is application layer traffic. So it's mostly like kind of a plain text thing. You can see everything like in plain text. So what we have achieved here, so the victim types something here and everything is sent to Bobsort here. So here we control the victim. So now how like we are controlling the victim because we are making the victim to be using our Chromium browser which we are controlling. So that's how we control the victim here. So that's how the whole scenario looks like. So I fish the user with go fish. So the phishing link has been clicked by the victim. So after the clicking the phishing link, victim will be viewing the no VNC GUI, which is nothing but the Chromium browser with the phishing website inside it. So whatever data is entered into the Chromium browser will in turn forwarded to Burp because we have configured it in such a way to forward the traffic to Burp So and this is one of the attack path. So I have another attack path as well, which I already showed you, which is the WebSocket history. So whenever there is whenever the user types here, you can open a WebSocket listener and everything will be logged into the WebSocket history and you can directly go inside the WebSocket directory like here and you can directly view all the uh, cat stolen credentials. You can see all whatever he has pressed everything will be showed here. So this is kind of a second scenario where you can just make the JavaScript and try to run it in the victim browser. So whatever he enters there will be executed and then like you can get this keystrokes here. So this is how the BITM attack works. So any doubts or any further enhancement needed, please do drop the comments under the video, so we will just try to make it more interesting. So thank you friends, like whoever just watched the video. If you do like this video, do hit like, share and subscribe and do support me and let me know if you need to see more contents or like you can even let me know like what content or which you are interested in so that we will try to make a lab out of it and we'll try to explore it. So it's nothing but like just grow as a group guys. So whatever you like to see, just let me know, like we will just try to work it out. Thank you guys, thanks for watching this video. I will just see you in another video. Until then, it's bye bye from Jairam. Bye bye.